Hi everyone. In this video I'm going to give an introduction to the Java Native Interface, or JNI. For those not familiar with it, it is a way for Java programs to interact with the world outside of Java. So in this case, we're going to use it to communicate with a C API. What I have here is an FTDI device connected to a Lattice FPGA, or I guess technically a CPLD, but close enough. And what I want to do is I want to use Java to communicate with the FTDI and transfer data to the computer. And the FTDI library is, of course, a C library, like most of them. And that means we need to use JNI to communicate with it in Java. And in this video, I'm going to show the entire process from start to end, all the way from the beginning of installing Java to installing the compilers and the IDE, writing the code, testing the code, and then finally benchmarking. All right, let's get started. Like my previous video where I explained the basics of the FTDI library, I'm going to do this in a VM, and that's simply because I want to show you the entire process without skipping a step by accident. Okay, so if you're watching this video, you probably already have Java installed and an IDE, maybe Eclipse or something similar. But again, I want to show the entire process because a lot of tutorials really kind of skip steps, and that can be annoying for beginners. So I'm going to start off with this VM that has basically nothing installed. It's Windows with updates installed and Chrome, and that's about it. So first we need to install Java. If you go to, what? Oh, that's weird. Okay, so I'm traveling and I'm using a VPN. It probably made Google suspicious. Anyway, so yeah, if you go to AdoptOpenJDK.net, go ahead and download Java. I'm going to go with the defaults of Java 8 with Hotspot. Okay, so yeah, if you run the installer, all of the default options are fine. One thing I'll point out though is there is an option to set the Java home variable. That's actually useful, but I'm not going to do that because you really shouldn't depend on it being there because a lot of people don't do that. But as we'll see later on, if you choose to have the Java home variable set, that can make it a little bit easier when you're setting up your Makefile. But for now, I'll leave it as the default just so that I can kind of show the I guess the more difficult way that you might have to tolerate if you don't. Okay, so now Java is installed. We have Java 8. Now we'll need to install the IDE. I'm going to use Eclipse. So if you go to Eclipse and then download and choose the 64-bit IDE. All right, we go ahead and run the installer. I just installed the JVM. Okay, so I maybe need to restart Windows for it to find the JVM. So let me try that. Okay, so I guess I had to restart after installing Java before the Eclipse installer could see the Java that I had installed. So there are many, I guess you could say, varieties of Eclipse available. We're going to use it for both Java and C development. So we're going to install just the Eclipse IDE for Java developers first. The default options are fine. All right, we can go ahead and run Eclipse. The default workspace location is fine. For those not familiar with Eclipse, the workspace is where Eclipse will save basically your preferences, your settings, all of your like configuration stuff. And by default, it is also where you store projects, although they don't have to be there. Anyway, so I'm going to go ahead and check to use this as the default. Okay, we can close the welcome screen. I don't need the task list. Close that too. Okay, so one of the first things you want to do is check for updates. So if you go to help, check for updates. Although we just installed Eclipse, it's possible that the installer you have doesn't have, of course, all of the latest updates. Usually it's pretty good, but occasionally I've had instances where it isn't all the way updated. And so you might be thinking, what's going on here? If you look down all the way in the corner, there's a progress bar. So if you double click, okay, so right when I double clicked, it finished, and it's telling me there was nothing found. But now we have a progress tab, which can be make things a little more obvious in the future. So that's good to have. Anyway, so there were no updates, which is fine. Now go to help, Eclipse Marketplace. And there are two different things we need to install. The most important is we need the CDT, which is the C and C++ development tools. So in the find box, type in CDT, and for Eclipse C++ IDE CDT, click install. As usual, all the defaults are fine. We'll need to accept the license. And again, yeah, if you didn't have this progress tab visible, you would just see this kind of hidden progress bar down here. So anytime you're wondering why Eclipse isn't doing anything, or why is it slow, if it is, just check in this bottom corner. That'll often give you a hint. And then we can restart the IDE. All right, we can close the welcome screen for the CDT. And let's install another plugin. So if you go to help, Eclipse Marketplace. This plugin is optional, you don't need it, but I find it very helpful, so I'm going to recommend it, but if you don't want to, that's fine, you can skip it. Search for Terminal. There is a plugin called TM Terminal. Basically what it does is it will let you have like a tab down here, or you could put it anywhere, I guess, but I keep it down here, where you can get the terminal. So I'm going to install it. So you might get this, I guess you could say warning or error. It still seems to work anyway. Not sure what's going on here, but go ahead and click yes. Go ahead and restart. All right, at this point, we're basically done setting up Eclipse. We'll come back to it in a little bit, but let's go back to the web browser. And so in my previous video where I covered the D2XX API, I used Visual Studio. And Visual Studio is great, but in this video I'm going to use Eclipse and GCC because in the future I would like to make this library cross-platform, and it's easier to do that if I use GCC. So to install GCC in Windows, there is kind of a variety of ways you can do that, and I use a, I guess a project called MSYS2, so MSYS2, and download the 64-bit version. And I'm going to go ahead and close Eclipse. We don't need that right now. Okay, so we go ahead and run the installer. All of the default options are fine. All right, so when you run MSYS, you get this terminal. And what we need to do is we need to update the currently installed packages. And there's a package manager called Pacman, and a couple of options to pass. So capital S, YU will basically update the currently installed packages. And the default of yes is fine. Press enter. All right, so the warnings or errors we saw earlier, in case you're wondering, it's just because my Wi-Fi connection is pretty slow. I'm currently traveling, and the Wi-Fi I have isn't very good, but everything's fine and ended up downloading. All right, and so at this point, it's telling me to terminate Emesis. Basically, what you need to do is you click the close button. And you get a warning, but that's okay. And we need to reopen. So go to Start, MSYS2, and MSYS2 MSYS. I'm going to go ahead and put a copy on my I'll drag it to my desktop because it is a fairly useful shortcut. And we'll go ahead and repeat the same command. So if you up arrow, it'll show the previous command. Press enter. And now it's actually looking for the updates finally. And the default option of yes to update is good. So press enter. All right, at this point we have finished updating Emesis, but we haven't actually installed the packages, or not all of the packages that we need. And so we can do that now. Okay, so we use pacman and then -s to install. And there are two, I guess you could say meta packages. They're not actual, they're like collections of packages. One of them is base devil, which is your kind of basic development stuff. And then there's mingw64, which is a 64-bit compilers and related tools. So press enter. And the default options are fine, so press enter. And again, default options are fine, press enter. And yet again, the default's fine, so press enter. Okay, so it finished installing everything. In case you're wondering, we really only needed some of these items. We needed GCC, make, GDB, that kind of stuff. But I installed all of it just because it wouldn't hurt and it doesn't take up a whole lot of space. It could be useful for other projects in the future. At this point, we can verify that we have, for example, GCC. Ooh, that's not good. Okay, so what we need to do is add to our path variable. So if you click start and then just type in path, P-A-T-H, go to environment variables, path, edit, new, and let's see, should be in C, MSYS2, mingw64 bin. That's one of the directories we need to add. So paste that, press enter, and there is one more. So if we go back up to MSYS2, we want to go into user bin. Copy that, paste it. Okay. So I can go ahead and close this and reopen. That's kind of weird. Why didn't it find that? Okay, can we find it from the Windows command line? There we go. Okay. So that's actually kind of surprising. I guess I'll have to look into why MSYS doesn't see it, but it doesn't really matter in this case because with it in the path, Windows and all the other programs, including Eclipse, can find it. And this is what we were hoping for because it means that we actually have GCC installed. Yeah, so we have GCC 9.3.0. Okay, what we can do now is just verify everything is working correctly. So in theory, we have all of our tools installed. They should all be working, but let's verify that. So we go ahead and open Eclipse again. I should point out that if you had Eclipse already open, you probably want to close it and reopen it because you edited the path variable, and so it may not see those changes until you open Eclipse again. So you go to File, New, let's do Project, C, C++, C Project, give it a name. Empty project is fine, and we're using min.gw. Some people like to switch perspectives a lot. I don't, so I'm going to choose not to, but either one is fine. All right, so now we have our empty project, and we can do File, New, Other, C, C++, source file. I'm going to call it main.c. And let's write a simple hello world. Okay, that's it. If you use Eclipse mainly for Java, you might be tempted to click the run or play icon. Don't. You need to build it first. So you can click here to build all. And let's see, we have an error. What did I do wrong? Oh, okay. Oh, I bet, okay. So I think I know what happened. The code that I wrote was fine, but the reason we got the error is I didn't save the file. And I guess if you build, it doesn't automatically save open files. So that was the problem. Okay, so we now know that GCC and Eclipse are working fine, and we can actually get to the JNI part of this tutorial. So let's create a new project, File, New. This time we can do Java Project. And in this tutorial, I'm going to cover the D2XX library from FTDI, like I mentioned at the beginning, and like I covered in my previous video. And I'm going to call this library Easy D2XX. If anyone's curious, there are a wide variety of libraries for Java to interact with the D2XX API, but I'm going to write my own just for a few reasons. One, just for fun, and also it's a fairly simple API, so it's a good introduction to JNI. It kind of it isn't too demanding, but it also has enough to where we can learn quite a bit. And also the existing wrappers and libraries, they're okay, but I just thought I'd kind of do it my own way and make it hopefully a little bit cleaner and easier to use in Java. So yeah, you name your project and click Finish. We can go ahead and close the Hello World project. So right click on it, close project. And in the Java project, we don't have anything. So we can right click, new class. All right, so I'm going to call the class EasyD2XX, and that is going to contain pretty much all of the code. And you don't have to, but I'm going to give it a package name of com.example.easyd2xx. All right, I'm going to go ahead and just write out the Java code real quick, and then I'll explain it at the end. So this is basically the entire portion of the Java code. that relates to JNI. And because with JNI, you're actually doing all of the work in C, C++, or some other lower level language, the Java portion is really kind of like a header where you define a bunch of methods that are native and you don't actually implement them. You just, it's like a function prototype. Anyway, so I have a class that I call EasyD2XX, and it has 5 fields. And basically, the name is a user-friendly name that would be shown to the user, so they can pick if they want to connect to this device. Chip name would be the integrated circuit, like FT232H or whatever it happens to be. Serial number is a string that can be provided to the user. Location is it's kind of like a handle, although it's not supported in every operating system. If I remember correct, it's only in Windows and maybe Mac OS, but it is not supported in Linux. And then if you open a device, we will get a handle and we will store it in this private variable. We don't want the user to be able to create any of these objects, so we have a private constructor. And what happens is anytime the user calls a method of this class, we need to make sure that the easyD2xx.dll file, which we will generate later, we need to make sure that has been loaded by Java. And so we do that by having a static block. And basically, we try to load the DLL. And usually people don't put this in a try-catch block. They just, if it fails, they let the program crash. In my case, I would like to catch the error and basically ignore it. Because what I want to do is, if for some reason the user does not have any FTDI drivers installed, I'd like them to be able to continue using the program with reduced functionality. So that's why I catch the error and I ignore it. In this case, if we get this error and we ignore it, anytime the user calls any of the native functions, they will get an unsatisfied link error. And it's up to them to catch that and degrade gracefully, of course. Okay, so I have only one static method, and it's just a helper to give the user a list of these classes. So for example, if we have 2 FTDI devices attached to the computer, this function should return a list of 2 items, and each item would tell the user a little bit about the device. The rest of the methods are object methods, like not static. And basically, for now, I only want to support the synchronous 245 FIFO mode of the FTDI communication protocol. And so I have a open as FIFO method, and the user can specify a read timeout and a write timeout. And as you can see, it'll throw an exception if there was a problem. Similarly, we have 2 read methods. They let the user read from the FTDI device. The user specifies the number of bytes to read. And depending on how the user wants it, they can either get a byte array, which is like the typical Java way to do things, or they can give this method a byte buffer, which is a slightly more efficient way to do things, which we will see later. I will benchmark it to show you. In both cases, it'll throw an exception if the read timed out or if the device is, for example, no longer attached or for some reason has failed. And then finally, we have a close method to close the device. So it's a very simple library. This is really just kind of a proof of concept. It isn't a complete library, of course, but I just wanted a useful example for this tutorial. To test the library, it would be a good idea to write another Java class that has a main method that we can use to, run the library and exercise all of the methods. So I'm going to create another class. I'm going to call it test, and I'm going to give it a main method. I'll go ahead and write the code, and then I'll explain it at the end. All right, so here is the test class. Basically, at the beginning, we call the getDevices static method to get a list of the devices. If there are none, we tell the user and we quit. If there are devices, we ask them to tell us which one to open, and we print out the information about each device. We then let the user type in the number, which would be whatever device number is shown here, they can type in. We then connect to it, and then we read 1 gigabyte using both read methods. So like I mentioned earlier, a byte array is typically how you do things in Java. However, a more efficient way is to use a byte buffer, because a byte buffer is more like a C array. Whereas if you use a regular byte array, a Java byte array, it copies it to the C function, and then when the C function is done, it copies it back into the JVM. So you waste a lot of time and a little bit of processing power doing that. We'll see later when we benchmark it, which is why I have the start and stop timestamps, and then I calculate the difference. And then finally, at the end, we close the device and we tell the user that we're done. If we get an exception, like for example, if we couldn't open the device, or if there was a read timeout or something, or if we get an unsatisfied link error because the DLL could not be found, then I print out the message, I tell the user I'm exiting, and then just for debugging purposes, I also print out the stack trace. So this is all of the Java code we need to write. The rest is now going to be in C. So in Eclipse, you can have a project that is both Java and C. And to do that, we take our current project, right-click on it, go to New, Other. In the C and C++ category, you can convert it. And we want to convert it into a C or C++ project, and the adds nature version. Click Next. Make sure the project is selected here. We're going to use C. And basically, if you use the first two options, Eclipse will manage the Makefile for you. It will kind of implicitly make one, but we're going to do that manually. So we go to Makefile Project and choose min GW GCC, and then go to Finish. And again, I'm not going to switch perspectives, but you can if you like. Since we are going to handle the Makefile ourselves, we need to create the Makefile. So if you right-click on the project, New, File, make sure the project folder is selected, and create a Makefile. Finish. And we want the Makefile to be basically here. We don't want it like, don't place it in the source folder, have it like in the root directory of your project. I'm going to define 3 different make targets for now, and we'll add more later. I'll explain them as I go. All right, so I defined 3 targets. First of all, because this is a very simple project, I like to keep the Makefile very, very simple. I know a lot of people like to have a bunch of variables and dependencies, and it makes everything nice and automated. But I find that for a simple project, that also makes it more indirect. And so I try to keep it very simple. And that's why I'm doing it this way. You might choose to add variables and everything, that's fine. So I have 3 different targets. The first one, which is called header, is used to make a .h file that we can use to write the JNI code. And I want to have all of my JNI code in a folder called JNI, which would be not in source, but in the root of the project, it'll be a JNI folder. So make dir-p will create that folder if it does not exist. I then need to compile my .java source code into a .class class. And then using the -h option, it will also save the header file into the JNI folder. And then we don't actually need the .class file afterwards, so I'm going to go ahead and remove it. These next two targets, sig and signatures, are entirely optional. I just put them in there because I don't want to have to remember the command to execute. And as we'll see later, when you write JNI code, you often have to reference a signature for a field or a method. And this is an easy way to look that up. So I will explain these two targets later. So we can execute these make targets either from the command line or from Eclipse. And of course, we might as well use it from Eclipse if possible. What we can do is if you go to Window, Show View, Other, Make, Build Targets. We now have a Build Targets tab down here. I actually kind of prefer to have it maybe here. I'm going to drag it there. Click on the project, and then you can click on New Build Target and type in the name of the target. So in this case, header. And if we expand it, you should see it. We can also click this icon to hide these folders. There we go. And unfortunately, we can't call this from within Eclipse because for some reason, the standard input stream is not connected to the command line, I guess, when it's executing the build target. So it won't work. But we can call this from the command line, which we will see soon. However, we can call this one from Eclipse. So I'll go ahead and add another build target, and I'll call it signatures. And to run the make command on one of those targets, you just double click. So we need to make the header file. So double click on header. And it says no rule to make target header. Oh, same problem as before. You need to save your file. Try again. There we go. So we got no errors. We now see we have a JNI folder, and in it we have a .h file. If we double click it, we see the stubs generated by Java to help us. Technically, you could write this all out by hand, but it's really complicated and annoying because you have to get everything just right, and the way they mangle names, it's all documented, but it's a pain. So that's why you use the Java C-H feature to generate it for you. As we can see, Eclipse is giving us a bunch of yellow and red squigglies, or whatever you want to call them, errors and warnings. And that is because there is an include JNI.h line up here, but Eclipse doesn't know where that file is. So we need to tell it. So if you right click on the project, go to Properties, go to C, C++ General, Preprocessor Include Paths, choose GNU-C, CDT User Settings, Add. We want to add an include directory. It's actually not in the project path, but elsewhere in the file system. So choose File System, and then we can click here. If you go to wherever you installed Java, which in my case, the default location was Program Files, AdoptOpenJDK, JDK, include. We want to treat it as built-in and as if it contains system headers. Okay. And do it one more time. Click Add. And this time, choose the Win32 subdirectory. Again, treat as built-in, contains system headers, and then apply and close. And we can see those yellow and red markers went away. One thing is, if for some reason it doesn't go away, it happened really quickly, but you might have seen a progress bar down here when Eclipse was rebuilding the index. In a larger project, that can take a while, so you might need to wait for it to realize that there are now headers that it can look for and process. If the errors and warnings don't go away, you can manually cause the indexer to run by going to Project, C, C++ index, and rebuild. In my case, it worked fine. Before I can write the JNI code to interact with the FTDI D2XX library or API, I need to download that API. So if I open up the web browser, search for D2XX, go to the FTDI website, and we go to Windows, 64-bit, and we want this version. Don't download the executable, we just need the zip file. All right, so we open the zip file. We're going to need to copy 2 files from here into the project. So let's open up another window. You can middle click to open up another copy. And you want to go to your Eclipse project folder. And if you left the defaults like I did, it'll be under C, users, whatever your username is, Eclipse workspace, and then EZD2XX. We're going to put the files in the JNI subfolder. So we need the ftd2xx.h file. That is the header file that we'll be using to interact with the API. Just drag and drop it. And then we need the .lib file. So FTDI provides the library in both static forms and dynamic forms. Unfortunately, I'd like to use the static form, but it doesn't link properly when using GCC. I think they compiled it with Visual Studio or Visual C++, and I think the way the symbols are set up or something isn't quite the same, and I just couldn't get it to work, unfortunately. So I'm going to use the dynamic library, which is fine. It's not that big of a deal. We'll go with the 64-bit version. One thing to keep in mind with JNI is if you use a 64-bit JVM, you have to make a 64-bit DLL. You cannot call a 32-bit DLL from a 64-bit JVM. So keep that in mind. And likewise, if you use a 32-bit JVM, you have to make a 32-bit DLL. So yeah, again, I'm going to go with 64-bit. So we go in that folder, and we just need the .lib file. So drag and drop. Okay, that's all we need from the zip file. We can close that. Back in Eclipse, we can right-click and refresh. And now we see the 2 files. Let's start writing the C code for the JNI portion of this project. We can just duplicate this file. So right-click, copy, right-click, paste, and just change the .h to a .c. All right, so I just kind of removed a lot of the junk that we don't need from the header file. Basically, we need to include that header file. And in this case, because I'm using the D2XX API, I need to include this header file. And we now have the methods we need, or the functions we need to implement. To make things a little bit easier, I'm going to give, well, not to make it easier, you have to give these arguments names. All right, so with JNI, the first argument you get with every JNI method is the JNI environment. It's basically a pointer to a pointer, which is how you access all of the functions that let your C code talk to the Java code. And then for a static method, like my getDevices method, you get a class or a J class. For a non-static method, an object method, you get a J object sent to your function. And then after that, you have any arguments that the function might take. So in this case, we have the read timeout and the write timeout. A JInt is the same as an int. So when using JNI, it's very easy to receive and to return primitives like integer or double. However, with objects, and that includes arrays, there's more work to it, as we'll see. Likewise, the rest of these, we have the environment, the object pointer, and then we have the arguments to the function. If you look up the JNI specification, so search for JNI, go to the Oracle JNI page, and then go to the specification. I recommend you bookmark this web page because it's really useful information, and it's basically all the information you need to use the JNI. It's not very long. You can read it in an evening, so I'd recommend that you at least skim through the entire specification. The historical background kind of explains part of why it's, well, to be honest, why it's so annoying to use, but why they chose to do it the way they do. The design overview kind of gives you a general feel for how to use the JNI, and then the JNI functions is the documentation for each function that we'll be using, and of course all of the information about it. So it'll tell you what parameters it takes, what it returns, possible error conditions, that kind of thing. All right, I'm going to start by writing the getDevices function, and then I will explain that, and then I'll continue on with the rest of the code. All right, I'll actually stop before I finish writing this function to explain what I'm going to do right now. As we saw earlier in the Makefile, we have a makesig and a makeSignatures targets, and this is why we need them, or well, we don't need them, why we want them. I'm going to, if you click on the project folder and then press Control-Alt-T, it will open up the terminal. That was the TM Terminal plugin we installed earlier, and it will open it in the folder that we had selected, which is what we want. If I type in makesig, it will ask me the class name. And in this case, that's actually what I want. I want java.util.list. And it will print out all of the descriptors. And as we'll see, whenever you need to reference a field or a method in JNI, it's basically all through strings because, of course, you lose a lot going from Java to C and C to Java. And so you need to tell it, in this case, we're asking for a method handle for the constructor, and the constructor has a, I guess like a magical reserved name, which is init inside angle brackets. And then we need to give it the descriptor, which tells you, or tells it which constructor. So for example, in Java util list, there is a, or actually, sorry, we don't want Java util list, we want Java util array list. All right, here we can see the constructors. One of them takes an integer, which if I remember correctly is the constructor where you can specify the default size. One of them takes no arguments, which is the one that I want. And the third constructor takes a pre-existing collection, and if I remember correct, it copies it into this array list object. But the one I want takes no arguments, and so we need to use this descriptor. So we can copy that and paste it here. And this, the reason why I have to use the terminal for this, like I mentioned briefly earlier, is if I add a target here called sig, if I double click on it, for some reason, Eclipse will not connect the standard input And so I can't type in the class name, which is why I have to use this terminal and then manually type in make sig. And while we're talking about it, that's really all this target does. All it does is it calls java p-s, and then in my case, it was java.util.ArrayList. But I added this target to the Makefile just as a convenience so that I don't have to remember that. I can just go to the command line, type in make sig, and it will help me out by doing the rest. All right, and then yeah, another slide before I finish writing the code. This is why I have the make signatures target. It's identical to the one we saw earlier, but we also want the -p to show the private the signatures for the private methods and fields. So if I double click signatures, now I have signatures for the class that I wrote. In this case, we have a constructor, and it has this long descriptor. All right, so this first function was actually probably the most complicated, so I'll go ahead and explain it. Once again, this is the get devices static method, and what it does is it will query the D2XX API for a list of all attached FTDI devices, and it will then give it to the user in the form of a list of objects. All right, so with JNI, it's kind of annoying because everything has to be kind of done with strings because you lose type information going from one language to another. But basically, we need a way to refer to the Java ArrayList class, and to do that, you call the find class function. The environment variable is a pointer to a pointer. So remember, you have to dereference that pointer and dereference it again. So that's why you have to do both. And then pretty much every JNI method takes as its first argument that environment pointer again. And in this case, we need to give it the class name. And you don't use dots between each like package section. You use the slash. So it'd be java/util/ArrayList. And another common mistake in JNI code is forgetting to check for errors. So in Java, if you get an error, you automatically get an exception. It's much easier to develop and quickly run it, test it, see if it crashes, kind of thing. You get a lot of detailed information in a stack trace. Not the case with JNI. With JNI, you're writing C code. So if you make a mistake, you can crash the JVM. You lose the safety of Java or a managed programming language, so you got to be careful. And pretty much every function from JNI that returns something, you need to check if it returns null because that indicates an error. So we need to check if list class is equal to null, and if it is, we need to return. In this case, it doesn't care what you return because there's already an error. What will happen is if you return, then the JVM will throw an exception for you automatically indicating the problem. If you forget to check for null and you just keep continuing and you keep doing things, you'll probably crash the JVM. So going on, we now have a, I guess you could say a handle to the ArrayList class. We now need to get a handle to the constructor for that class. And like I mentioned earlier, we used the getMethodID function. You need to give it, of course, the environment. Then you need to tell it what class the method belongs to, not the object, but the class. And that's why we had to call this earlier. We then need to tell it the name of the function. And again, the constructor has this magical name of init with the 2 angle brackets. And then we have the signatures, which is what the make signatures or make sig targets are for, to help you with. Again, check for null and return if there's an error. We can then create a ArrayList object. So this is equivalent to, in Java, it'd be new ArrayList. So we call the new object function. We give it the environment. We tell it what class we're trying to create a new object of. And then we tell it which specific constructor, because again, a class can have more than one constructor. And then if the constructor took arguments, you would just have a comma, and then you would put your arguments afterwards. In this case, there were no arguments. Again, check for errors, return. We then need a way to call the add method on our list. So again, we get a handle by calling getMethodID. You give it the environment, you give it the class, you give it the name of the method, which is add, and then you give it the signature of the add method, which again is why we have the, or in that case, the make sig target. We need to get a handle for the constructor for our EasyD2XX object. Again, similar thing, the environment, the class, the method name, the method signature, check for errors. All right, finally we get to the the meat of the function, the part that actually does something useful. This is calling the FTDI D2XX API. So we need to call the create device info list function. It will return a D word, and in this case, it's the number of devices. If you haven't seen my previous video, there's a link to it in the video description below, and that will explain the FTDI D2XX API. In that video, I did this all in Visual Studio, but it's pretty similar here, and I cover all the documentation for that API in that previous video. All right, so with this API, we have to allocate space with malloc. So we need to create enough space for a number of structures. We then call the function to populate the list, and then we iterate over that list, and we create an easy D2XX object for each FTDI device. So before I can call this constructor, I need to have the things I'm going to give the constructor. So I need to give the constructor the name, the chip name, the serial number, and the location. So strings in Java are slightly special objects. They have a little bit of special treatment. And in this case, you call the new string UTF function. You give it the environment, and then you give it a C string, which in this case was provided by FTDI. It's one of the members in this struct. It will copy that C string into our Java string, and the handle of our Java string is name. Keep in mind that a J string is not a C string. You cannot just print out this in C. It's basically a handle, so just keep that in mind. With chip name, the FTDI API basically returns an enum in the type field, and to make it more user-friendly, instead of just returning like the number of the enum, I convert that into a user-friendly string. So for example, the enum ft device bm, I will, if that's the case, I define chip name to be ft2232bm, and so on and so on. So this is just the ternary operator, the question mark colon. It's, if you're not familiar, it's just a big long if, else if, else if, else if, and so on. So that's this huge long thing. And then back down here, we have the serial number, which again, we call new string UTF, and the location. And again, luckily with primitives like integers and doubles and floats, that kind of thing, they're the same. You don't need to call any JNI methods. They're magically able to work, thankfully. It's the only easy part of JNI is primitives. We now have these objects and primitive, and we can call the constructor. So I need to get a reference or a handle on that. Or no, I'm sorry, we got that earlier. I need to create the object. So I call a new object, I give it the environment, I tell it what class, which happens to be the same class as we were using earlier. I give it the handle to the method, or I'm sorry, a handle to the constructor. And then here I just pass in the arguments to the constructor. So because I take a string, a string, a string, and an int, I pass it my JString, 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 and JInt. Again, you always have to check for errors manually. So you check for null. If you have a null, you need to return. And in this case, because I used malloc to allocate space for the FTDI device list, I free that space and then I return. Now we have an easy D2XX object, and I want to put that into the list of objects we are going to give back to the user. When you call a method that returns something, you'll use something like this. So in this case, I need to call a function or a method that returns a Boolean. So you use call Boolean method. As usual, you give it the environment. You give it the object that you're going to call the method on, and then you give it the method handle. So in other words, I want to call list.add. So I give it the list object, and I give it the add handle, and then I give it the arguments. In this case, the argument is an object, so I give it my JObject. It's possible for a Java function to throw an exception, and again, you have to check for that as well. So you use exception check. If that returns true, you have a problem, and you're supposed to exit your JNI function. So again, I have to return the malloc to memory, and then I can return from my JNI function. If we don't have any problems yet, then we successfully used the D2XX API to get the list of information, and we successfully populated a Java array list. So now we can free the malloc to memory, and we can return that array list back to Java. One more interruption before I forget. So with the signatures, it's important to remember that everything they show is part of the signature. That semicolon is not the end of a statement. It is part of the signature. So make sure you include that. If you don't, it won't work. All right, so the open as FIFO function or method is very similar to the one that I wrote in Visual Studio in my previous video. Of course, this is obviously adapted for JNI. In preparation, we need to figure out which class the current object is. So because this method belongs to an object, it is given the object, which is this in Java, but it is not automatically given the class. So we need to get the class for the current object. Then, because I might manually throw an exception, I need to get a handle on the exception class, which is what I do here. I then need to get a handle on the chip name class because I'm going to try to connect to the device by name. So I need to read the chip name field. I need to read this. And so I use getFieldID. And again, I need to tell it which class. I need to tell it the name of the field, and I need to give it the signature. Then I use getObjectField to get the chip name of this particular object. So that's one of the kind of interesting things is for the handle to a field, you get that for the class, not for the object. But then when you get the actual field, of course, you have to get that for the object. So you use the J object instead of the J class here. All right, so like before, we need to convert that into a C string. So you can use get string UTF-chars. That will return a constant C string. You can then use string compare to check, and the FTDI documentation says that only the FT2232H and FT232H support the 245 synchronous 245 FIFO mode. So if the device is not one of those two, I'm going to manually throw an exception and return. Anytime you call get string UTF-chars, you are supposed to release that C string before you leave your C function. So you need to release that, otherwise you'll have a memory leak. And then I throw the exception and then I return. If we don't have a problem, I still want to release that C string because I'm done with it. Now I get into, again, kind of like the meat of the function where I actually use the D2XX library. I create a handle. I need to get a handle on the Java location, the location field. I need to get the value of it once I get the handle, and then I can use that to try and call FTOpenEX. Because of the way the FTDI API is, it expects it to be a pointer, even though we're giving it a integer. The API calls it a pointer because you can open by location, or you can open by name, or you can open by serial number, and so it just always takes a void pointer. So I take my integer, I then cast it as a unsigned integer pointer, and then as a void pointer. You can actually leave out this part. However, I believe I ended up adding that because on 32-bit Windows, I had problems where you'd get compiler warnings about a mismatch between pointer sizes. So if this function does not return FTOK, that means we have a problem. And that could be because we're on Linux, where it does not support opening by location, in which case I try to open by name. So again, I have to get a handle to the name field of the Java object. Then I have to get the actual string, and then I have to convert that into a C string. And then I call FTOpenEX again, this time trying to open by description. If that does not result in FTOK, then I have another problem. I can't recover. So I release the C string that I obtained from JNI, and then I throw an exception so that Java knows that I can't open their device, and I return. If we get to here, then we were able to successfully open the device, and there are no problems so far. Then the rest of this is basically FTDI code to set up for FIFO mode. So I covered I covered all of this in my previous video, but we need to set it up for synchronous 245 FIFO mode, minimum latency, maximum buffer size. You have to enable flow control to work around a data loss problem in their API, which is covered in one of their application notes. Empty the receiver FIFO and transmit FIFO, and then set the timeouts based on whatever the user requested. If any of these functions fail, then we have a problem, and I throw a new exception. If none of them failed, then we succeeded in opening the device. in which case I need to save the FTDI code populated my FTDI handle, which happens to be a void pointer. I need to save that in my Java object. So I get a handle on the handle, so to speak, which I decided to call FTDI handle because I couldn't think of anything better. So I get that handle, and then I use set long field, which will let me write to a primitive from JNI. And so again, you give it the environment, you tell it what object you are manipulating, you give it a handle to whatever, in this case, whatever long you want to write to, and then you give it the value. And so again, because FTDI handle is a void pointer, I have to cast it just to make it not complain. Technically, it'll work if you leave this out, but you'll get a compiler warning if you leave it out. In this read method, this is the version that returns a byte array. Similar to before, we need to get a handle on the class. We need to get a handle for the exception class. We then need to read the handle. We need to get this value from Java. So I get a handle to the handle, and then I get the actual value from Java. Again, I cast it as a unsigned integer pointer. You only need that part, I believe, in 32-bit Windows, or maybe it was Linux, but I was trying something earlier and I had to add that to solve a compiler problem. But then we cast it to an FT handle and store it in this variable. To create an array from JNI, you use one of the new array functions, in this case a new byte array, and you give it the environment and then the number of elements for your array. As always, check for errors. And then the JByte array is not the actual array. It is, again, just a handle. Like most things in JNI, it is a handle. So you then use the getByteArrayElements to get a pointer. So you give it the environment, you give it the handle of your JByte array, and then this option, if I remember correct, it will tell you if it's a copy. So in this case, I don't care if it's a copy or not because I will do the same thing either way. So I can give it null because I don't care. If you care, you can give it a pointer to a Boolean, and then it will populate the value of that Boolean with true or false accordingly. All right, so this is our pointer to what happens to be 1 gigabyte of memory, because in this example, we're allocating 1 gig of memory, or we're requesting 1 gig. This is basically just D2XX code to read 1 gig of data. Well, actually, because this is a library function, it doesn't read 1 gig, it reads whatever you ask for. But of course, in this case, I'm asking for 1 gig. So basically, we need to split it up into multiple transactions, possibly, because we can only read up to 64K at a time with the FTDI API. And so I have a loop where I keep track of how many bytes I actually got, how many more I need, and I populate the Java byte array accordingly. If I get an error, I throw an exception, and that could happen, for example, if my FPGA stops sending data for some reason, or if the device gets unplugged, like if I unplug the USB cable, that could happen where it can't read. If we don't have any errors, then we finish, and we need, anytime you access a Java array, you also need to release the array elements. And so you give it the environment, you give it the array handle, and then you give it the pointer that you were provided earlier. and then you can return. All right, this version of the read function is for putting data into a byte buffer. It's very similar to the previous read function. However, we don't use an array, of course. What we do is we need to get the pointer of that belongs to the byte buffer. And so you give it the environment and you give it the byte buffer object, which happened to be an argument of this function. It will return a void pointer. And again, as always, you need to check for errors. To be a little more robust, I verify that the size of the byte buffer is big enough to actually contain the requested amount of data. And so you can call get direct buffer capacity and then compare the size of the buffer with the requested read size. If there's not enough room, I throw an exception to tell the user and I return. Otherwise, I simply read into the byte buffer, similar to how it worked in the array version. All right, and the final function is close, which is very simple. Basically, as usual, we need to get a handle on the class, a handle on the exception class, and then we need to get a handle to the handle. I then call the ftClose function, and if that does not return ftOK, I throw an exception to tell the user that we were not able to close the device. Otherwise, it succeeded, and we return. So that is all of the JNI code. Okay, now we'd like to compile the JNI code into a DLL. Let's add another Makefile target. All right, so I added the DLL target. Basically, we call GCC. We give it the path to our JNI.c file. In this case, I'm writing some code that uses the FTDI D2XX library, and so I also need to compile in their .lib file. Just like we told Eclipse earlier, we need to tell GCC where to find the Java include files. And that was here on my system. Your path might be a little bit different depending on which Java version you have installed and where you installed it. And again, there's two different include paths. There's the include folder and then also the Win32 subfolder. And then for a DLL, you add -shared and then -o and then your file name. These last three lines are optional, but they provide some useful information. File will give you a little bit of information about the file type, which I mainly care about because I want to verify that I'm compiling a 64-bit or a 32-bit DLL. In this case, 64-bit, but it's useful to have that just as a kind of a sanity check. Especially later on, if you're going to support multiple platforms, it's good to verify that you have everything set up the way you hope you do. NM will print out information about the exported symbols in the DLL file, and we only care about the ones that start with Java. I just want to verify that the functions that I defined in my .c file actually end up in the DLL. Again, this is really just a sanity check thing. You don't have to have it there. And again, LDD is also another sanity check. It just tells you how various parts of your DLL map to other DLLs on your system, which we'll see shortly. Finally, I add an all target, which is the target that is automatically called if you just run make without a target name, and I tell it to make the DLL. So save the make file if you haven't already, and we can go ahead and add another build target. I'll call it DLL. And let's see if I get any compiler errors. So double click DLL. Okay, good. So if we scroll up, we see that GCC did not print out any errors, so that is good. Luckily, I typed everything out from my notes correctly. Surprised by that. Like I mentioned earlier, file will tell us a little bit about the file. In this case, it is telling us that we have a DLL for 64-bit Windows. And M tells us a little bit about the contents of the DLL. And again, I just wanted to verify that the functions that I have in my source code actually ended up in the DLL. This is a good example of why I like to have LDD in my Makefile, because in this case, we did not get any compiler errors. But if we try to run the program, it will not run. And this is part of why. What happened is my DLL, the ezd2xx.dll file, it compiled fine. However, it is dynamically linked against the FTDI d2xx driver. And right now in this VM, I do not have that driver installed, which is why LDD cannot find the required DLL. So let's see what happens, because you might run into this problem and it can be very frustrating. So, okay, everything is saved. Let's go ahead and run the test. Run as Java application. It will call make all automatically, and then it'll run the Java program. And we get this unsatisfied link error. And it happened the first time we called the native function, which happened to be the call to get devices. And you might be thinking, well, what's going on here? I have my DLL. I'm sure it contains the files that I wrote, or the functions that I wrote, but it won't work. And that is why. This is why you have a problem. Just because Java found your DLL does not mean it could successfully load it, because your DLL might depend on others. So in my case, I'm going to fix that. I am going to now plug in my FTDI devices, and we will install, or we will let Windows install the driver. Okay, because I'm using a VM, I have this popping up. I want to connect the devices that I just plugged in into my virtual machine. All right, now if I go to Device Manager, if you right-click Start, go to Device Manager, we'll see we have 3 yellow triangle errors. I can have Windows automatically install the drivers. So right-click, Update Driver, search automatically. That's surprising. Okay, let's try. Oh, okay, I guess it automatically. Oh, it was probably installing automatically in the background, and then when I opened up Device Manager, it was like in the middle of installing, so it had the yellow triangles, and I think it just finished installing. Yeah, I think so. Let's verify. Let me go ahead and reopen Device Manager. We have no errors, so I think Windows automatically installed the drivers without even telling us, which is good. Now all I need to do is rerun LDD. I can do that, but I'm just going to go ahead and recompile to make it easier. You do not need to recompile. And now we can see that it found everything we needed, including the FTDI DLL. So that is why I like to have LDD in my Makefile. It's just a good sanity check that can save you a lot of grief. Let's go ahead and try to run the test again. All right. So here we have 3 devices found. If you watched my earlier YouTube video, which is again linked in the video description, I cover how this first device is part of my FPGA development board. The second device is also part of the FPGA development board. This is actually the JTAG interface. And the third device is the FTDI that I care about. It is the one that is going to be reading data from the FPGA. So I want to read from device number 2. I'll go ahead and type in 2, press enter. And we have a Java lang out of memory error. Interesting. Does my VM have enough memory? Huh, okay. So I needed to allocate 1 gig of memory because I'm transferring 1 gig of data, and I only have 0.9 gigs free. All right, let me change my VM real quick. Okay, we're back. I now have 8 gigs set aside for this Windows VM. Let's try again. Okay, so I think I didn't reconnect the, yeah. Okay, let me reconnect that to the VM. All right, that was just a problem because I'm using a VM for this tutorial. Should not be something you encounter. All right, so here we are again. I'm going to try to read from device 2. So I'll press 2, press enter. So I was wondering why I couldn't actually read from the device. And it's because when I reattached them to my VM after restarting, now my UM232H device is device number 0, not device number 2. It isn't able to read from device number 2 because nothing's attached to that interface. So let's go back to the Java perspective. Okay, yeah, it's device 0 that I want to read from. So 0, enter. And you guys can't see it, but there's a light on my FPGA development board that has lit up. All right, so here we have it. I was able to read 1 gig of data into a Java byte array, and it took 23.3 seconds. If I read it into a Java byte buffer, it took 22.7 seconds. So that's about 1 second faster, or it looks like maybe, what, 4% faster? So the reason for that is a byte buffer is basically like an array in C. It's a contiguous sequence of bytes in memory, and you can interact with it in C or other programming languages very easily. Whereas a Java byte array is actually not guaranteed to be contiguous memory. The JVM has allowed a lot of flexibility to allocate things however it sees fit to optimize, and that's why. And so, for example, if you ever use Java libraries and they want you to use byte buffers or float buffers or any of the other buffers, that's why. And once again, if you look up the Java JNI specification, I really recommend that you read through this. Again, it's a relatively short document, or I mean, it's not a short document, but it's a 1 evening or a 1 day read. It's really useful, and particularly you're going to want to read the JNI functions page because that explains kind of everything that I, magically knew. Is just because I skimmed through this and read a few web pages as well. So if you have any questions or comments, leave them down below. I have a link in the video description to my previous video, which covered the FTDI D2XX API when using Visual Studio, and it kind of went into more detail about the FPGA and the FTDI and how they communicate. And I also have a link in the video description detailing all of the code that I showed in this video. So you don't have to read it off of my screen. You can take a look at the web page. In my next video, I'm going to show how to package the DLL file inside of a jar so that you can more easily use this JNI project as a library. And perhaps more importantly, I will show how to make a cross-platform JNI library. In Java, you are used to being able to take your jar file and run it on pretty much any operating system and any architecture, and it works. But with JNI, it's specific. So for example, we just created a DLL that'll only work in Windows and only in 64-bit Windows. But in the next video, I will show how to do it for 32-bit Windows, 32-bit Linux, 64-bit Linux, Mac OS, and maybe even the Raspberry Pi, which is an ARM version of Linux. And I'll show how to package all of those into a single jar file so that you can easily use it just like any other Java library, and you now have the cross-platform abilities that you're used to. All right, I hope this video was helpful. If you know anybody that might benefit from it, please share a link with them.